Hi folks, this is number 18 from page 106. So this is a bit of a different question. They ask us to show that the tangent to this curve at 1, 3 is also tangent to the curve at another point. Okay, so just to get an idea of what this could look like. Okay, and imagine, say I have a curve that looks like that, and say at this point I got a tangent line. Well, this same line could be tangent to the curve somewhere else. Okay, so this is what we're trying to figure out. Okay, so the first thing we should do is determine what this tangent line is. Okay, and we know that we can use this point because the curve and the tangent line are going to share this point, so it's just a matter of determining the derivative in order to find the slope of the line. Okay, so here to find the derivative of y, we just have to use the chain rule on that first portion. So again, this expression in the bracket is like my u. So derivative of u cubed is just 3u squared. So 3 times x squared plus x minus 2 squared times the derivative of this inside portion. So just 2x plus 1. Okay, and the derivative of 3 is just 0. So no contributions there. Okay, so now let's find the derivative at the specific value 1. And here, when we put that into the equation, we just get 1 squared plus 1 minus 2. And we see here that this expression is just going to give us 0. So in fact, we're dealing with a horizontal line. Okay, so what we have to first find is what x values provide a slope of the tangent, which is also equal to 0. Okay, so I'm going to work with my derivative, which I've already found, and I'm just going to set my derivative now to 0, because I know that the other point I'm looking for is going to have the same slope of tangent. Okay, so here we've got 3 times. Now this looks like it's factorable, so we have x plus 2 times x minus 1, okay, all squared, times 2x plus 1. Okay, and here we see that the x values at which are going to make this equal to 0. Well, we're going to have x plus 2 can be equal to 0. Okay, x minus 1 equaling 0, but looks like that was the point that we already dealt with, and 2x plus 1 equals 0. So I'm going to deal with here x equals negative 2 and x equals negative 1/2. Okay. Now, what we found here, actually what we should have found was the actual equation of the tangent. Okay, but since this is just going to be a horizontal line and it passes through the point 1, 3, we know that the tangent has an equation of y equals 3. Okay. So essentially, since this tangent line is y equals 3, we know that the y values are always equal to 3. So essentially what we have to do is figure out if either of these two x values on the curve generate a y value of 3. Okay, and if it does, that means that we found the point we're looking for. So here, if we take negative 2 and let's stick that into our equation, we've got negative 2 squared minus or plus negative 2 minus 2 cubed plus 3. Okay, and so here we have 4 minus 2 is 2, minus 2 is 0, 0 cubed plus 3 is equal to 3. Okay, so that means what we have is the point negative 2, 3. At this point here, the slope of the tangent is also equal to 0, hence the show you there. The tangent also has an equation of y equals 3. Okay. Now, could be that there was more than one point. Maybe this also has a y value of 3. Hence, its tangent will also be equal to y equals 3. So let's just test that out. Okay, so here we've got negative 1/2 squared plus negative 1/2 minus 2, all cubed plus 3. So essentially we see that this is going to have to be equal to 0 in order for the whole thing to be equal to 3. So here what do we have? We have 1/4 minus 1/2 minus 2 cubed plus 3. And it's very clear that this is not equal to 3. Okay, so while the slope of the tangent is still 0, at x equals negative a half. Okay, the tangent line is not actually given by y equals 3. But because this point here at x equals 2 is actually at x equals negative 2 is at negative 2, 3, and the slope of the tangent is equal to 0, it means it also has a tangent line of y equals 3. Okay, so just to recap, number 1 was to determine what our tangent line was. Okay. Number 2 is to find all other x values that had the same slope of the tangent. Okay, in this case here we had 2 possibilities. Okay, and to determine which one of these 2 generated a tangent line with the same equation as